Hi guys, and welcome to another past question revision. So we are going to try to model a mass spring system in the following question. So determine the system equation x of s divided by f of s, where m is equal to 10 kg, b is equal to 30 newton per meter per second, and k is equal to 20 newton per meter. Now this is the mass system that we want to model. So how do we go about this? So I'll show you how to do this, and we'll be done in a very short period of time. So solution. So first of all, you need to draw the free body diagram. So in drawing the free body diagram, you should take note of one particular stuff. You need to assume your own sense of direction. So choose a reference direction. So that direction you choose becomes your positive. So everything that goes contrary to that direction is negative. Is that okay? So when drawing a free body diagram for any kind of system, choose a reference direction. So usually the reference direction should point in the direction of the displacement, or in the direction of the applied force. If there is an applied force and input force, let the reference direction point in the direction of that input force. So in this case, our reference direction is down, so down is going to be positive. So you're not thinking that usually down is negative and all those kind of stuff. No, this time around you've changed your down in your mind to positive. So this is your reference direction. So with this, we're going to draw what? The free body diagram. So drawing the free body diagram is drawing all the forces that act on the mass. Okay, force that acts on the mass. So this is our mass. Now we have the input force acting on the mass. That's our F of t. So what are the forces that are in resistance to this input force? Now, according to Newton's second law of motion, inertia is going to be a resisting force. So inertia, okay? So inertia is proportional to the acceleration of this body. So you have the value of the mass times what? Acceleration. That's d2x over dt squared. Okay, so inertia is in the opposite direction to the applied force. Another force in the opposite direction to the applied force is the damping force. The damping force is proportional to the velocity, and the proportionality constant is b. So you have b dx dt. Is that okay? Then another force that is actually in position to the mass is actually the spring or the elastic force. According to Hooke's law, that force is kx. Okay, so this is the free body diagram. So we have hooks, then we now have what? Damping. So this, our reference direction, has opposing forces acting on it. So we are now going to use the D'Alembert principle. So using the D'Alembert's principle, the algebraic sum of forces acting on a particular system is 0. So our reference direction is positive. I have f of t, then all of that forces are negative. So you now have minus m d2x over dt squared minus b dx dt, then minus you have kx is equal to 0. So if you rearrange it, you will have m d2x over dt squared plus b dx over dt and plus kx is equal to f of t. So I'm putting it like this because I like saying output variable is equal to input. Okay, so remember, you're targeting this particular expression, this transfer function, output over input. Is that okay? So that's what you want to develop. So now that you've gotten this differential equation, maybe the question could be obtain the differential equation that relates the input and the output. So this is where you stop. But if they say find the transfer function, you need to take the Laplace transform of both sides. So taking the Laplace transform of both sides of equation star, okay, and this time around 0 initial conditions. Remember, when taking Laplace transform, we usually assume initial conditions, but when you're taking Laplace transform for control system, we usually work with 0 initial condition. So that will make this particular one m. So the Laplace transform of the second derivative is going to be s squared x of s. Okay, that's all. Then plus we have b. Then the Laplace transform of the first derivative will be s to the power of 1 x of s. Then plus we'll now have the Laplace transform of x is going to be x of s, so you just have kx of s. Then the Laplace transform of a particular f of t can be represented as f of s. Is that okay? So you can now factor out x of s, so you have m s squared plus bs, okay, and you now have plus k. Everything into x of s is equal to f of s. So when we divide, or when we find the ratio x of s divided by f of s, we'll find out that this ratio is equal to 1 divided by ms squared plus bs plus k. So if we substitute the value of m, b, and k that was given to us, so let me try to capture them: 10, 30, and 20. At the end of the day, our x of s over f of s is going to be 1 all over 10s squared plus 30s plus 20. And this is the system that we are actually looking for. So this brings us to the end of this video. I hope you understood how to do it. So we'll solve another mass spring problem, hopefully some electrical problems, and yeah, that will be it. Thanks. Like this video, subscribe for more, and stay blessed.